So we talked about non-permissible values. Do you remember what non-permissible values are? Yeah.
Something that equates the denominator to 0.
Something that would equate the denominator to 0, and we can't have our denominator equal 0, so we have to find out what that is, right? And then we just say what they can't be. What's another word for non-permissible values? Yeah. The restrictions. They're just interchangeable, right? So if they ask you for non-permissible values, you could say, well, x equals 7 would be a non-permissible value. So you could actually say equal to if you say non-permissible value, because that's what x equals 7 would be, one that's not permitted. If you say restrictions, you'd have to say like x can't equal 7. That would be the restriction, right? I just say not equal to all the time. We don't have to. Now, what we've only dealt with so far is we have only dealt with NPVs, correct? But now what we're actually going to do is simplify, but we are always still going to have to state NPVs. So let's look at this first one. We're going to do the NPV for it first. Where does the NPV only come from? The denominator, right? Now, this is the catch. If you have something attached with a plus or a minus sign, they're sewn together, right? So if you have like x plus 2, x plus 2, you put them in brackets. But if it's two things multiplied, you can put them in their own separate brackets. So are the 2 and the x attached by plus or minus signs in the denominator? No. So we're going to put them in our own brackets. This is a monomial and a monomial. Remember terms? One term is a monomial. It means it's not attached by plus or minus signs. Whenever you have monomials, you put everything separately into a bracket. So we're going to go the 2 in its own bracket and the x in its own bracket. Because they're multiplied, right? Two things multiplied can go in brackets. Side-by-side brackets means multiplication. True statement? Yes. Can the 2 cause me any problems? The number 2. Can it ever be 0? No, it's the number 2. If you want to, you can show it over here. You can say 2 can't equal 0, which is just a true statement. But remember, I told you it's not actually an NPV. Our other one is x. When it's just by itself, we say x can't equal 0. Now remember, we can check it. If we plug it back in, if it is a true NPV, if we plug it back into the denominator will equal 0. True statement? Yes. Owen, right? Yeah. So if I put a 0 in here, I go 2 times 0 and I get what? 0. So it is an NPV. It's right. And it's the only one. Perfect. Now not yesterday. Yesterday? What is today? Today is Monday. Friday? Remember last Monday when I told you all to have a good weekend? But it was Monday? Yeah, I feel like I'm back there. All right. So on Friday, you weren't here, but that's okay. On Friday, we talked about non-permissible values, and that was it. But now we're actually going to simplify the top and the bottom. So we actually care about the numerator now, because it says, express the following rational expressions in simplest form. What that means is I find what's the common between the two, and I cancel it off. Okay? So I look at the 12 and the x squared, and they're multiplied, so I can put them in their own brackets as well. And I say, what can I take out of the 12 and the 2? Because they're both numbers. 2. 12 divided by 2 is 6. And 2 divided by 2 is 1. Now, the top we have, do you want it a little more zoomed in, Sam? He's like squinting hard. But it's not helping. Is that any better? It's kind of fuzzy, but. All right. We have an x squared in the top, and we have an x in the bottom. What can I take out of each of those? An x, because x squared is just x times x. True statement? All right. So this squared can cross off one of these, and then this is an expression. It's not an equation. Expressions don't have equal signs. Equations have an equal sign, yes? So if I'm going from one expression to the next, which is the simplified expression, I have to remember to do what along the left-hand side? Equal signs. So this equals what? Now make sure you have equal signs running down the left-hand side, because when I do like item writing and stuff like that, or validating of diplomas, and there's profs in the room, they tell us that no one knows how to put equal signs, that there's arrows randomly all over the place, and no one knows what to do. And I don't want that to be you. You're going to walk in and the prof's going to be like, these kids are geniuses. They were taught so well. It's me. It's all for me. Okay? To me. It's all about me. Right, Caleb? Okay, so we run an equal sign down the left-hand side, and what's left in the numerator? 6x. What's left in the denominator? Do I have to write a 1 if it's left in the denominator? If it's left in the numerator? Yes. So you write your simplified expression, and you still have to follow behind with the non-permissible value. X can't equal 0. Now, people will tell me, well, there's no x's in the denominator anymore. I don't need a non-permissible value. What you need to remember always is non-permissible values need to be stated before you cancel anything off. So if at any point in time there is a non-permissible value, it has to be stated. Even though we canceled it off and it's gone, we state NPVs always before we cancel. So before we go to cross anything off, we slap our hands and we're like, have I stated my NPVs? If I have not, I state my NPVs. Okay? Done. Now we look at B. So, is there anything more I can do to that? It's a nice simplified form. People actually do these worse than the other ones because you think there's got to be a trick. When they're easy, I'm actually scared because you guys do them worse. All right. So if I look here, a plus 1 is attached by a plus sign, hence the bracket, correct? A minus 6 is attached by the minus sign, hence the bracket. Same thing on the denominators. True statement? So, before I go to cancel off, and I see a plus 1, they're going to cancel, I get super excited. But before I get excited to cancel off, I slap my hand and I say, state NPVs. So, I'm going to go off to the side, I'm going to say a minus 7 can't equal what? And if it did equal 0, this whole bracket would be 0. 0 times that is 0, right? So that's why we set each bracket not equal to 0, because that whole bracket, if it became a 0, we'll cancel the whole denominator out, making it be a 0, and we're in trouble, right? Then we have a plus 1 can't equal 0. And I need to solve them. What do I do here? Add. Yeah, a can't equal 7. And a can't equal -1. And they often write them together as can't equal 7, comma, -1. And I'm always going to write that in the end. All right. Is there anything I can cancel in the numerator and the denominator? Yeah. What can I cancel? And I'll answer it once. A plus 1. I can cancel the a plus 1s off. So, in my first few years of teaching rationals, I thought, man, I am so awesome. They are going to do great things. And then I would see the quizzes. And you guys oversimplify. You'd like cross off more things than possible. You never, most often it's not that people don't simplify enough, it's most often that people are like, I can do more. And then you like cross off this A and this A. You can't do that. This is an A minus 6. It is sewn together. True statement? It's like the A minus 6 is me. And the A minus 7 is Caleb. We both have heads, aka A, but do we look the same?
No.
Trick question. We do not. I know, very similar, but we do not. Now, this is a plus 1, a plus 1. These are twins. Do they look the exact same in every single way? Yes. So if you have plus signs between something, you put it in brackets, and the only way you can cross off brackets is if they match completely with those binomials, because it's two terms together, right? So the a plus 1 and the a plus 1 completely cancels off. But the a minus 7 and the a minus 6, yes, the a's look the same, but that a is attached to the 6 with a minus sign. So that is like me, or Caleb, I think, and then this is like me. We are not the same. We cannot cancel each other off. So you can't get any better than this, those of you who try and cancel a's off after this. Do you think they'll have the answer 6/7 on the diploma? Yeah. It's scary when that gets picked, because it's completely incorrect. A minus 6 and a minus 7, not at all alike. I am done. I can't go any further. I write an equal sign down the left-hand side. I have a minus 6 in the top, a minus 7 at the bottom, and a can't equal 7, -1. So if something is attached by a plus or minus sign, the only way it can cancel off is if it has a twin. In every way. Okay? Our monomials totally different. Like an x and an x can cancel, a 12 and a 2 can cancel because they weren't attached by plus or minus signs. So let's look at 6. And by 6, I mean C. Doesn't even start with a 6. 6 starts with an S. Cool. So this is what I get. bad. First off, I should have done what? NPVs. Second off, I should have brackets, and then this would be attached, and then I would say this is 8y plus 2, and this is 8y, and they're not the same. Right? So many bad things happened right there. So, ooh, that's an aggressive eraser. So I'm going to put the 8y plus 2 in its own brackets together, because, sorry, people will say only the y plus 2 are attached. No, the 8y is together, the 2 is together, the 8y plus 2 are attached. I just did that. Didn't mean to. It got a little tilted. All right. 8 and y, is there any plus or minus signs between them? No. So these are like holding hands. They can just go in their own brackets. Right? Because 8 times y is 8y. So you can put it in brackets. Now, does the 8 get me any NPVs? Can 8 ever be 0? I can say 8 can't be 0. Good job. True statement. Does nothing. Right? And then I have y can't equal 0, and I've done that one. Now I say to myself, I cannot cross off those 8y's. On the top I have an 8y plus 2. The only way it's going away is if I have an 8y plus 2 on the bottom. Do I? No. But can I do something to the 8y plus 2? Remember we practiced this GCF difference of squares. Can I do anything to the 8y plus 2? You take out a 2. And then that goes in its own brackets. Remember I told you it looks silly, but write it in its own brackets in front. And then we go 8y divided by 2 is 4y. Now this is where things go awry. People will say 2 divided by 2, gone. What is 2 divided by 2? Plus 1. Now I told you to catch that mistake. Pretend distribute back and see if you get what you got, right? GFCs, GCFs, what is a GFC? That's chicken, or KFC, Knights of Columbus, all these options. GFC, I'm going to Google it. All right, GCF, when you take a GCF out, you can check by redistributing it back and see if you get what you got. So, 2 times 4y is 8y, cool. 2 times 1 is 2. If you got rid of that plus 1, you would have 8y. Is that what's up top? No. The other thing is, when you take a GCF out of 2 terms, you better still have 2 terms in the brackets. Remember, taking out a greatest common factor just reduces the bracket. It doesn't get rid of any terms. It just reduces each term, right? So, and then on the bottom, I have an 8 and a y. Now, I look at this 4y plus 1. And because it has a plus sign, I say, is there a 4y plus 1 in the bottom? No, that baby's staying for life. It's not going anywhere, right? Now, in order to get rid of the y on the bottom, I'd have to have a y by itself, or a y squared, or a y cubed by itself, or a y to the 4 by itself. Do I have anything up here like that? No, so that baby's staying for life. What about the 2 and the 8? You can take out a 2. So 2 divided by 2 is 1. Remember, whenever you're taking them out, you're doing division. 8 divided by 2 is 4. And so I'm left with 4y plus 1 over 4y. Now this is why I told you, if it has a plus sign, to put brackets around it. Want to know why I say that? Because I've taught this so many times that I've watched the illegal math that happens at this very step. I get 4y and 4y canceling, like way more than it ever should. 4y plus 1 are attached, correct? They're sewn together, plus sign. So if I put brackets around this, is the chance decreased that you will cancel those off now? Yeah. If you put brackets around it, I promise you, you will think twice before you go and cancel those 4y's off. Okay? This is a 4y plus 1 sewn together. It needs a twin. Remember when it's a binomial, when there's 2 terms attached by a plus or minus sign, you need to have that twin on the bottom, do we? No. So that's staying for life. I can't do anything with this. It can't get any better. And I just say y can't equal 0 behind it. Now, whenever it asks you to simplify, what you should actually do first, and we haven't been doing it because we haven't had to, when it says simplify, the very first thing you should always do is go to the numerator, see if you can take out a GCF or difference of squares. Go to the denominator, see if you can take out a GCF or difference of squares. Every single time before you go to do anything. Because remember, that's what we did for MPVs. We went to the bottom and saw if we could take out a GCF or a difference of squares before we stated MPVs. So, for D, can I do anything to the numerator? Numerator? No, right? So on the numerator, we're going to leave it as a negative x plus 7. Now, technically, we could take out a negative 1, right? We could take a negative 1 out. But until we know if we actually have to, I just leave it sitting. What is the bottom? Yeah, difference of squares. So I take the square root of 49 and I get what? 7. And I take the square root of x squared and I get what? So I'm going to get them in the order. You can't put them in the order you feel. Just because you like having x first doesn't mean you can be like, I'm just going to write it as x plus 7, x minus 7. You can't do that, okay? You have to write them in the order at which they happen. So 7 happens first, correct? So 7 has to go in the front of each bracket. X squared happens last, so x has to go in the back of each bracket, and then I put plus, minus. What do I need to do before I even try and simplify anything off? NPVs, right? If before I get excited, like I can cancel things, I slap my hand and be like, I need to state NPVs first. And I have 2 brackets, so I'm going to get 2 NPVs. I'm going to get 7 plus x can't equal 0. 7 minus x can't equal 0. This one I'm going to get x can't equal negative 7. This one I could actually add the x over. It would get me there faster than moving the 7 and dividing by negative 1. So I get 7 can't equal x. So I have x can't equal plus or minus 7. Now here's where the trick lies. I have a whole bunch of binomials sitting up there. And by a whole bunch, I mean 3. I have 3 binomials, correct? I have to see if any of them are the exact same. And by exact same, I mean twinning. And by twinning, I mean the exact same term with the exact same sign in front of it. Yeah? So, on the top here, I have negative x plus 7. Could I rearrange that? Could I change the order of it? Yes. I just need to make sure that when I rearrange the order, what sign is in front of the term follows. So, I can go, these ones are starting with 7s, right? So if I want to rearrange it so this one starts with a 7, I can. But it's a positive 7, true statement. So 7 has to start. And then I have a minus x, so I have to follow it with a minus x. So do you see that it doesn't matter what order it's in, but what sign is in front of the term has to follow it. So this is a positive 7, negative x, and then these I just rewrite. Now do I see something? What do you see? 7 minus x are twinning, correct? Can I cancel off twins? Why would I give this question like this? What do you think I'm setting you up for the error? Forgetting to do what? Yeah, put a 1 where? In the numerator. They'll give an answer like this on the diploma every single time. That's your answer. But it's wrong. If your denominator completely cancels off, you don't have to write the 1 in the denominator. True statement. But if the 1 is canceled off in the numerator, remember all these slash lines, they're just fancy ones. Every single time you cancel something, it's just a fancy slash 1. I still have a 1 in this numerator. I need to write it. Because if you don't write it, you're saying that a quarter is the same as 4. Is that a true statement? Is that correct? A quarter is the same as 4? No. So I have to write the 1. Can I say that 4 over 1 equals 4? Is that correct? 4 over 1 equals 4? Yes, every number can be written over 1. So if it's just in the denominator, I don't need to write it. If it's in the numerator, I do need to write it. I'm going to move that so you don't think it's part of this. And then I have to follow behind with my NPVs. I don't know what you're saying. X can't equal positive or negative 7. And then I box it. What the heck do I have to do to E? first step for simplifying is GCF difference of squares, the numerators and the denominators. So what can I do to the numerator? Take out a, yeah, 8p, oh, smaller, 4p. So I'm going to go an equal sign, right? And then I'm going to go 4p. And then I write what I take out. So 12p squared take out of 4p is 3p because it's division. And then negative 8p divided by 4p is negative 2. What do I do with the 4 and the p sitting in front? I can put them each in their own brackets, right? Because the 4 and the p are multiplied. And I know it looks silly, but trust me, it makes people get more answers correct. So I'm going to do it. What can I do to the denominator? Take out a 2p. See if you can get the NPVs. So this I can take out a 2 and a p. When I take a 2p out of 6p cubed, what am I left with? 3. Oh, instead of taking out a 2p, what did I take out? 2p squared. So 6p cubed, take out a 2p squared, I'm left with 3p. And then minus 4p squared, take out a 2p squared, I'm left with 2. And I'm seeing things matching, and it's making me feel a little more confident in what I'm doing, right? Things should match. Before I go and cancel these off, which I have to stop myself because I see things that match and it makes me excited and I really want to start simplifying because I realize I'm not stupid, right? I have to stop myself and be like, wait a second. What do I need to do first before I cancel? NPVs every single time, okay? So I have 2 can't equal 0, true statement, not a problem, cross it off. P squared. P squared is like having what? P times P. So if I have a p or a p squared by itself or a p cubed or p4 or p5 by itself, it's just p can't equal 0. Because technically I could write this as 2 times p times 3p minus 2, right? So I would have p can't equal 0 twice, but I'm just not going to write it. So if I get a p squared or a p cubed or a p4 or p5, it's right, p can't equal 0. Then I have 3p minus 2 can't equal 0. 3p can't equal 2. And I never skip this step because some of you will write 3 halves. You'll flip it in your head when you do this. So I always divide by the 3. Stated my NPVs. Then what can I do? Yeah. I can cancel off. So the 3p minus 2 is an exact twin of this one, and they're binomials, and they have to be exact twins or they cannot cancel. The 4 and the 2, I can take out a 2. What's 4 divided by 2? 2. What's 2 divided by 2? 1. And the p and the p squared, can I cancel something out of them? Yes, because p and p squared, remember p squared is just p times p, is it not? So when you take 1p out of here, you can just cross it off there, right? You'd be left with a p. So I don't have to show it this way, but proving a point. So what is left in my numerator? Now remember this. These are all just slanted ones, correct? So this is technically 2 times 1 times 1 times 1, which is 2. And on the bottom I have 1 times p times 1. P. I aggressively made this longer than I needed to. Better than shorter. So there's that. I'm going to knock it down a little bit so I can put my MPV. Wow. Wow. Okay. And I have to follow behind with my MPVs. P can't equal 0 or 2/3. So just so you know, tomorrow we are going to be